Hey there, we're going to continue studying U-Substitution and we're moving on to definite integrals. So now we're finding the area between the curve and the x-axis, or the net change area within the curve. So here we have the integral from negative the square root of 3 over 2 to 0 of 1 over the square root of 1 minus x squared dx. Now, is this an integral that we can do just by looking at it? And if the answer is yes, then you just write what the antiderivative is. If the answer is no, then you want to check, okay, can you rewrite it in a way so that you can then do it by just looking at it, right? Using either the general power rule or some of the basic antiderivatives that we know, and then, or U-substitution. And for U-substitution, we ask ourselves, does the derivative of one part equal another part of the problem? Here, I recognize this as something that we can just do by looking at it, right? 1 over the square root of 1 minus x squared is the derivative inverse sign. So that means that here I can just go straight to the fundamental theorem of calculus and say this is going to be f of b minus f of a, which in this case is going to be f of, right, when you see this, the limits, your a is the one on the bottom, right? This is your interval a to b. So then is f of b, so f of 0 minus f of negative root 3 over 2, where f, capital F, from the fundamental theorem of calculus, is the antiderivative. So here, well, I recognize that this is the antiderivative. This is the derivative's inverse sign, so that means this is going to be inverse sign of x from negative root 3 over 2 to 0. And so then we can evaluate. So this will be inverse sign of 0 minus inverse sign of negative root 3 over 2. Inverse sign of 0 is just 0. And what about inverse sign of negative root 3 over 2? So here you have to remember your values for the trig functions. And also keep in mind that sine has a very specific, or sine inverse has a very specific domain, right? You go from, on sine, you go from negative pi over 2 to pi over 2. That's where the function is 1 to 1. So that means that the values for inverse sine are going to be between negative 1 and 1. So negative root 3 over 2 is going to be a value in the third quadrant. But between negative pi over 2 and 0. So this is, what's the value? So 0 minus negative pi over 3. That's our reference angle. Pi over 3 is the reference angle. So then this just becomes negative times a negative becomes positive. So pi over 3 will be the area that between this curve and the x-axis from negative root 3 over 2 to 0. And however you choose to remember your values, I know in many of my previous videos, I have shown you my table where I have theta, sine, and cosine, and we start with just the reference angles, the angles in the first quadrant, 0, pi over 6, pi over 4, pi over 3, and pi over 2, right? Except for 0, these are the denominators of pi, and sine is 0, 1, 2, 3, 4, so these are square root of over 2, and cosine, you just reverse it. So when I look at, for sine root 3 over 2, I'm looking at this, oh, so my reference angle is pi over 3. But because I need to be between negative pi over 2 and 0, then my angle is actually negative pi over 3. So that is the final answer for that one. All right, let's try now one where we may have to use U-substitution. All right, so let's try this one. The integral from 0 to 49 of dx, or you can think of as there's an invisible 1 there. So 1 over the cube root of 27 minus 2x quantity square. So it's not something I can do just by looking at it, so I'm going to make a U-substitution. And following what we talked about in the previous video is U is oftentimes thing inside parentheses, inside radicals, in denominators, or the powers of exponentials, and so on. So here I have something in parentheses, so I'm going to let u be that 27 minus 2x and see if that helps us. So du then will be minus 2 dx. And that seems to work because at least I get my dx. I don't get the constant, but that's okay, but I get a dx. So then this, what is the new integral with this substitution? And you can solve for the dx, right? So dx will be minus 1/2 du will be dx. So the new integral will be minus 1/2, put it on the outside, and then 1 over the cube root of u squared du. And now this I can write as a general power rule, right? I can say negative 1/2, the integral of u to the negative 2/3. If I leave it on the bottom, it will be 2/3, right? U to the 2/3, but bring it all the way to the top, du. Now here we have a choice to make. Do we want to integrate and then go back to x's, or do we want to change the limits of integration? And changing the limit of integration means we want to change, these are x values, right? X equals 0 and x equals 49. So we want to change 0 to 49 on the x-axis to something else on the u-axis, right? Because we're making a change of variable. So we can do that using our substitution. So since u is equal to 27 minus 2x, that means that when x is 0, the bottom limit, what's u? U is 27 minus 0, so just 27. So the bottom limit was 0, so now that becomes 27. The top limit is 49, so when x is 49, u is what's that? 27 minus 2 times 49. So what is that equal to? And that's negative 71. So we can put that in there. And I know some of you are going to be like, wait, what? Why is that the positive and that's negative? This should be backwards. Don't worry about it, right? That's how it just translates. This is the transformation. Once you get to Pascal 2, Pascal 3, perhaps into linear algebra, and you do more transformations, you'll see why that is. Actually, you'll probably do transformations in Calc 3, and so you'll be able to see why that is. So you're just in a different plane now. You're going from the xy plane to the u something else plane. So it just works out this way, that when we change the variables, my limits look a little weird. If you're uncomfortable with that because you're like, but the negative should be at the bottom, then you can change them, right? But then that means you have to change the sign of this using the property that the integral from b to a of f of x dx is equal to negative the integral a to b of f of x dx. So you could do that. I'm not going to do that. I'm just going to leave it like that. And so now I have negative 1/2 the integral from 27 to negative 71 of u to the negative 2/3 du. And I can integrate. So what do? We add 1 to the exponent, so it will be u to the negative 2/3 plus 1, so it will be negative 2/3 plus 3/3. So to the 1/3 divided by 1/3 is the same thing as multiplying by 3. And I don't do a plus c because this is a definite integral. So now I have from u equals 27 to u equals negative 71. So this is the thing that you have to be careful. What I don't want to see you do is say change the variable to u and then still have 0 to 49 here. Be careful about making that small mistake, right? Because you've changed the variable. Now you have u's, and if you leave 0 to 49 here, those are x values. All right, so then we plug it in, or you can simplify it if we want. So it'll be negative 3/2 the cube root of u, and then from 27 to negative 71. And so I'll have negative 3 over 2 the cube root of negative 71. It's okay to take the cube root of a negative number. We just can't take the cube root of a, the square root of a negative number. And then minus, and then plug in the 27. So minus a minus 3 halves becomes plus 3 halves, the cube root of 27, and that we can do. The cube root of 27 is 3. So our final answer will be negative 3 halves, cube root of 71, plus 3 halves times 3, which is 9 halves. So let me write the 9 halves first. So it'll be 9 halves minus 3 halves, cube root of negative 71. If you want to put that on a calculator, you can. 71 is not a perfect cube, so it doesn't have a perfect cube root, but you can definitely put that in a calculator. And the cube root of negative number is negative, so this is really going to be positive, right? Negative times negative will become positive. But I prefer my answers in fraction or the radical form just because they're more exact. So let's try another example. The integral from negative 1 to 1 of the square root of 1 minus x squared dx. If it was 1 over that, then I recognize that as the inverse sign, but unfortunately that's not what I have. And so do we recognize it as something that we can just, is this the derivative of something we know? No. Can we do a U-substitution? That's the derivative of one part equal another part of the problem. No, right? If you try, we can let u be 1 minus x squared, but then du is negative 2x dx, and I don't have an x dx. So this brings up a good discussion point that your du, right, when we compare the variable part, I have to at least have it somewhere in there. So I can't have u's and x's mixed up. So I can't say like, oh, well, there's my dx. So I'm going to solve for dx and say, right, negative du over 2x is dx, and then make this integral somehow the square root of u over 2x du. This does not work. So be careful about that, right? So you cannot have two variables in one integral, unless one of them was a constant, like if it was pi r squared, right, and then dx, and the r is a constant. So you can't do that. So be careful about doing things like this. So I can't do it just by looking at it, and I can't do it by U-substitution. So what do? Well, maybe we can do it geometrically. So let's try doing this area geometrically. What do I mean by geometrically? Do we recognize that function or that graph? So let me rewrite it over here. So the integral from negative 1 to 1 of the square root of 1 minus x squared dx. So the function is this thing, right? So f of x. So that means that f of x is the square root of 1 minus x squared. But f of x is just a fancy name for y. Square both sides. And so this, when you move the x squared over, I have x squared plus y squared equals 1. Do we recognize this guy? Yeah, this is a circle centered at the origin with radius 1. And so when this is asking me for the integral from minus 1 to 1, this is the area along the x-axis of this function, right? So I'm essentially looking for the area between the circle and the x-axis. So let's graph what that looks like. So if I graph my circle here, then with the radius of 1, that means that's 1, this is negative 1, that's 1, and this is negative 1, and this is x squared plus y squared equals 1. Now the problem with this is that, right, if you solve again for y, you're going to have y squared equals 1 minus x squared, and then how do you get just y by itself? y equals plus or minus, you have to take the square root of both sides. So here, the top one is really f of x equals the positive square root of 1 minus x squared. So let me repeat that. So just the top half of the semicircle is what this integral represents. If I wanted the bottom half of the semicircle, this function will be negative. So I'm looking at the area between minus 1 and 1 of the top half of the circle and the x-axis. So we're looking at this area. So can I find that area? Sure, right? What is the area of a circle? The area of a circle is pi r squared. So here's just the area of half a circle. So that means that the integral from minus 1 to 1 of the square root of 1 minus x squared dx is half the area of a circle. Of the circle shown, I should say. The circle radius 1. So this is going to be 1/2 pi r squared. R is equal to 1. So just 1 squared is 1. So just pi over 2 is the area. So oftentimes when you have definite integrals, if we can't solve them from the methods that we have learned in this class, then ask yourself, can I graph that? Can I do this geometrically? Because it might be a line, it might be, like in this case, a circle, or it might be an ellipse. And so then you can just draw it, figure out what portion of the area you want. Because I could have also said, how about the integral from minus 1 to 0? And then that will be a quarter of the circle, right? From minus 1 to 0. When you're looking at when I say from minus 1 to 0 and minus 1 to 1, you're looking at, these are x values, right? X equals minus 1, x equals 1. So you're going from here, from x equals 1. So if you were going to approximate it, you will be doing your delta x's up and down. So you're moving from minus 1 to 1 to x equals 1 there. If I set to x equals 0, then it will go to x equals 0 here. So it will be just a quarter of the circle. All right, let's try the next example. All right, so for this one, this is a really interesting one. So can we do it just by looking at it? Right, is it a standard, a basic antiderivative? No. So can I do a U-substitution? Does the derivative of one part equal another part of the problem? Kind of, right? When I see this, I said, oh, I can look at, well, let u equal 4 minus x squared. We've talked about how oftentimes u is the inside of things, inside of parentheses, inside of radicals. So if I let u equals 4 minus x squared, du is then minus 2x dx. And this is just the wrong thing, right? Because I have minus 2 times x, and this is x minus 2. So this isn't quite right. But this is what makes this problem interesting. I can rewrite this problem to separate the integral. So distribute your radical. So take this radical, the square root of x, and multiply it to those, right? That's a binomial. So you can, and this is a monomial. So multiply it in. So this is going to be the integral from 0 to 2 of x, the square root of 4 minus x squared, and then minus 2, 4 minus x squared, and then dx. And now we can use our properties of integrals to separate the integrals. So this will be the integral from 0 to 2 of just x times the square root of 4 minus x squared dx. And now notice, ta-da! Well, I can use this substitution with this integral because there's my x dx. So I can use that substitution. And then minus the integral from 0 to 2. So let me bring this 2 out of the square root of 4 minus x squared dx. And what do you notice about this one? We can do this one geometrically. Hopefully by now, geometrically. You recognize this as a circle. Oh, this is a circle, a radius 2. And this I can do by U-substitution. U-sub and geometrically. So let's do the substitution for the first one. So here, I already wrote it up there, but since it's not in the frame, let me just redo it. Let u be 4 minus x squared, du is minus 2x dx, and then I recognize my x dx there, so solve for that, right? When you find your du, compare what from your du appears back in the problem, the x dx. So x dx is equal to du over negative 2, so minus 1/2 du essentially. Let me write it that way. It sounds better. Minus 1/2 du. It's better for the substitution as well. So then I can get my integral there. And what do I mean by geometrically for the next one is we can say this is a circle of radius 2. So that's 2, that's minus 2, that's 2, that's minus 2 on the y. And this is asking for the area of the circle, right? How do I know that this is a circle? Again, this is f of x, which is y really. So y equals the square root of 4 minus x squared, square both sides. Get the x's and the y's together. So that's a circle, center at 0, 0, or radius 2. But this one's the area from 0 to 2. So here's 0, there's 2. So I'm looking at chopping up this area, right? So I just want a quarter of the circle. So this will be 1/4 pi r squared, because it's just a quarter of the circle. So let's continue with the problem. So for the first one, my new integral then is the integral with this substitution is x dx, that's negative 1/2 du. So let's write the negative 1/2 outside, and then this is the square root of u du. If you want to change the limits of integration, this will be a good time using that substitution. So using this substitution, so then when x is 0, the bottom limit, what's u? U is 4. And the top limit when x is 2, what's u? So 4 minus u squared. So 4 minus 4, which is 0. So this will be the integral from, now bottom limit goes with bottom limit, top limit goes with top limit, so it will be from 4 to 0. I know, that may look weird because you're like, but the smaller number is usually on the bottom. That's okay, we did a transformation, right? So we changed the variables, so our variables are not lining up. But if it's really bothering you, then you can use the property that the integral from b to a of f of x dx is equal to negative the integral from a to b of f of x dx, right? So if you want it to look pretty, if you wanted to say from 0 to 4, then I can use this property, and then this is going to become, since that's negative, when I put the other negative there, that's going to become positive 1/2 the integral then from 0 to 4 of u to the 1/2 du, plus the area of a quarter circle, of radius 2. So let's see, antiderivative of this, add 1, so this will be u to the 3/2 times 2/3, and then we still have the 1/2 out here, from 0 to 4, plus 1/4 pi r squared. And so my 2's cancel, so we're left with just what, 1/3. Plug in the 4, so 4 to the 3/2 minus 1/3, 0 to the 3/2, plus 1/4 pi times 4. So those 4's are going to cancel off nicely, divide out, and so let's see, that becomes just 0. So 1/3, 4 to the 3/2. So how do you evaluate this? Do the radical first, right? The half means the square root. Square root of 4 is 2. To the third is 8. So you're going to have 8/3 minus 0 plus pi. So it'll be 8/3 plus pi. So that will be our final answer. So this is one of those nice little problems where you have to separate them and then be able to recognize it, like, oh, one I can use a U-substitution, and then the other one I'm going to do it geometrically. And the last thing that I wanted to share with you is a meme I saw for a coffee shop. And let's see, I'm taking too long copying it. So they had this somewhere for the Wi-Fi password, and it was the integral from -2 to 2 of this. And so that was the password. So this says the Wi-Fi password is the first 10 digits of the answer. So can you figure out what that answer is? So that is I'll leave you with that question. And you may see it. If you search for it, you'll be able to find it, but I encourage you to try to actually solve it. It's very similar to the problem that we just did. And in fact, it uses the fact that when you have an odd function, the integral on a symmetric interval of an odd function is 0. So some properties of integrals. So if f of x is odd, then the integral from -a to a of f of x dx is 0. And if f of x is even, then the integral from -a to a, so a symmetric interval of f of x dx, is equal to double the integral from 0 to a of f of x dx. And the reason for that is, like, if you have an odd function, right, and you're going from -a to a, if you have an odd function, that means that the areas cancel out. The net area is 0 because you have a negative area here and a positive area here, but they're the same in absolute value. So this area is 0. When you have an even function, that means that you have symmetry on the interval, right? So from -a to a, so I'm going to take a nice parabola, for example. So then you have symmetry here. So these areas are the same. So from 0 to a is going to be the same as the area from -a to 0. So you just double the area. Double on 0 to a. And so that's where those come from. So back to the problem that we just did, right? A much easier way would have been to notice that, oh, well, this is an odd function, right? Because the square root of 4 minus x squared is even, but that's odd. Odd times even is going to be an odd function. So this is an odd function. Had I been on a -2 to 2 integral, I would have just said that's 0. So if this had been x times the square root of 1 minus x squared, then that would be 0. But, and then here, had that been -2 to 2, then that first integral will be 0. But because it's 0 to 2, I have to do my U-substitution. So now looking at this one, what you would have to do is take, just like we did with the other one, take the radical and distribute it into the functions. You have a binomial here. You have the x cubed cosine x over 2, that's one term, and 1/2 is the other term. So distribute that in, and then you'll be able to see what happens here. So good luck figuring out the free Wi-Fi password for that coffee shop. But with what we've done, you guys can totally do it. All right, email me if you have any questions.